organizers for giving me the opportunity to present my findings to the Hellenic medical community in the UK. And then I'll go right on, sharing with you information that made us ask the question whether we can use the fruit fly Drosophila melanogaster as a genetic model for a condition called restless leg syndrome that, in our best understanding, is associating with deficiency in the movement, in the limb movement, and in impaired brain iron metabolism. Now, restless leg syndrome has a prevalence of 10% in the general population, and 5.6% are affected in the UK population. General increased activity and abnormal movement of the limbs during the night are currently our best behavioral markers, with patients displaying diurnal deficits and impaired brain metabolism, iron metabolism. Now, although there is no cure for RLS, FDA-approved drugs falling under the category of dopaminergic agents. However, iron supplements are given in order to ease the effects. Now, considering all this, we asked the question in order to evaluate the potential of using an invertebrate organism. We asked the question whether there is a connection between iron metabolism and the circadian clock of the flies. Now, we know from previous research in molecular biology and genetics how the molecular clock works. We have good insights of that, and also the main components for iron homeostasis. Therefore, to address the possibility of a link between these two areas, we used Drosophila reverse genetics and performed a screen where we downregulated the expression of genes related in iron metabolism using a clock driver. What we have found is that after we silence the ferritin heavy chain homolog and the ferritin light chain homolog, we get lethality and arrhythmia respectively. Now, how do we assess the behavior of the fly? Well, we can simply do that by switching off the lights. That way, the endogenous clock arises, takes over, and drives the rhythmic activity that we can see in an output that is called an actogram, where each row represents the days of monitoring over time. The white areas indicate daytime, the gray areas indicate nighttime, the blue bars indicate activity, something that you can see is consistent after we switch off the lights on the third row. So therefore, the flies are like us. They are active during the day and they are resting during the night. They also have, if you can see on the first rows, what we call the siesta. So they do take a nap in the middle of the day, like we do back home, especially. So, however, in clock mutant flies, this rhythmic activity is lost after we switch off the lights. Therefore, that indicates an endogenous clock dysfunction. What we have noticed is that after we silence the ferritin light chain homolog, we get a very similar phenotype as the clock mutants, something that suggesting an endogenous clock dysfunction. Now, after comparing the phenotype with our controls, they had proper rhythmic activity, and since we had a reproducible effect relevant to RLS, we sought to investigate the physiological functions of these flies. So the first thing that we did was to go to look at the neuronal clusters that are responsible for driving the rhythmic activity of the flies. And what we have found is that the three groups of the lateral neurons and the 4 groups of the dorsal neurons of the fly responsible for driving rhythmic activity were intact in the rhythmic flies. Therefore, that way we have excluded cellular lethality. The second thing that we did was to directly assess the central clock, and we simply did that by measuring the mRNA expression of two genes that code for proteins essential for proper clock function. So what we compare and what you see here are double plots of 2 experimental conditions in light, dark, and constant darkness cycles for 2 genes in control flies. So what we compare are the peaks that we know that are around at late in the evening, between 7 and 9 o'clock. So as you can see, there is that peak, and we switch off the lights, it persists. And the same for that gym, there is that peak just before we switch off the lights, and it persists after we switch off the lights and control flies. So what we have noticed, that one of the two genes, the period in the arrhythmic flies, has both peaks, whereas when you switch off the lights, the other gene is called timeless, it's completely dampened. Therefore, we had a second indication of endogenous clock dysfunction. Now, after molecular and cellular characterization of these flies, we also analyzed the systemic function, the systemic function at the organismal level. Now we know that an indicator for total iron levels in the flies are the accumulation of iron ferritin in the middle mid-gut in the fly intestine, like we say liver for humans. So what we found out was a severe effect of iron overloaded ferritin when we compared the rhythmic flies, and when we switch off the lights, this effect was induced. Therefore, we had two interpretations to discuss here. One was that we were able to see the overall effect that the silencing had in this organism, and secondly, we speculate that this might be an emergency mechanism to reduce the risk of iron-catalyzed cell oxidative damage. Now, these results sparked the idea of to do another experiment, very simple experiment, was to simply measure iron levels over time in order to see if iron fluctuates in flies. What we have found out is two reduction effects that are associated with the LD cycle because they are evident after the lights on and the lights off events. Therefore, this result comes with increased interest because first, there is no report to show that iron fluctuates in flies, and secondly, we're very curious to see if this trend persists in our rhythmic flies, something that we haven't done yet. So we have three pieces of information that provide us with clues of a link between iron metabolism and the circadian clock, and at the same time, I believe, dictate us to continue the work of unveiling the underlying reason of this phenotype. So that was it, more or less. I want to thank my mentor, Dr. Fanny Smith-Lees, Professor Stanesky for his assistance on the clock side of this project, Carla and Lucia for some experimental help, and the rest of the Fly Lab that they do little things to help and push forward this project. Thank you very much for your attention.